My name is Ivan Rodriguez. I'm the Technical Programs Director for INCOSE Canada chapter. Today's presentation, it will be a short one because we want to get into our AGM, but I think it's going to be a really good one and something that we can all use in our day-to-day as we deal with leaders and decision makers in our organizations and in our community. So Ivan Taylor is going to carry on here to present just to introduce Ivan, he's president and senior researcher at Policy Dynamics. Ivan has a master's degree in information and systems science and a PhD in public policy. Ivan's very involved in INCOSE, and in fact, he's provided several presentations for us here in the Canada chapter, but Ivan also presented a couple papers at the International Symposium in Dublin earlier this year. He's presented for an international workshop, the social systems and resilient working groups, and continues to share his knowledge with our community. So thank you very much for that, Ivan. Please share your screen, and we'll sit back for your presentation here. Thank you.
Sorry, I thought I was sharing already.
Okay, no, I should have said something. There we go.
Okay, thanks, Ivan, for that great introduction, and I'm very happy to present today. This is something that I hope everyone will find useful. The way I'm set it up is it's intended to be an extension of an elevator speech for senior leaders. So it tries to explain why systems engineering is a smart investment. So it's short and it's got some nice numbers attached to the value of systems engineering. And like I said, if anybody wants to use these slides for their own presentation to leadership or to anyone, just contact me or contact the board of directors, and we'll get those slides to you. And like I said, you can do whatever you want with the slides. But okay, let's take a look at the presentation. So the first thing I say is, what is systems engineering? And again, this is for leaders, so they don't necessarily know what systems engineering is, and actually they probably don't even care what systems engineering is, but I'm going to try to convince them that it's a smart investment. So anyway, systems engineering is about making sure the whole system works together. So we're about systems as we've seen, and integrating things together. And so it's an interdisciplinary approach for understanding customer needs early, designing, testing, and validating systems, and managing complexity and integration of subsystems. So as I said, we're systems engineers, and we're integrating systems together. And we want to make the whole system work properly. Okay, so one of the benefits of early systems engineering investment is that more systems engineering upfront means fewer surprises later. And there's a reference here that I show that says that spending 12 to 14% of the budget in SE at the start can save 50% or more overall project cost. So this is an important idea that I'm trying to present is that leaders are very interested in the bottom line. They want to know about how this is going to affect their profit and their costs. So this is a demonstration that, yes, systems engineering is going to save some money for you, a significant amount of money. And then the next thing is a similar thing, a value of early systems engineering. So the way we save money is we avoid costly mistakes. And basically, by getting in early, because fixing problems later in a project can cost up to 250 times more than fixing them early. So, that's huge. And so I have a reference for that too. So you can look at that reference if you're interested. And then the last statistic I want to show is return on investment, ROI. and that's always important for leaders. And so for every dollar spent on systems engineering, we can save $4 to $10 by avoiding mistakes, rework, and project failure. And like I said, rework is a huge expense for projects. So we want to avoid that. And the way we do that is by getting the requirements right early. And I'll get into that. Okay, so here's how systems engineering works. This is my own impression of how to explain systems engineering to someone who doesn't know what systems engineering is and maybe, like I said, doesn't even care. So the problem, well, first of all, we understand the problem and what success looks like. Second, we explore all solutions and make sure the best fit together. So we're working very early in the project to make the systems that we select fit together. So we're looking at the system. And then we prepare the system for testing and support early. So we're going to basically do very early work to make sure we can test the system and support it in the future. Then we manage and track requirements so nothing is missed. And we ensure all the parts of the system fit together and work smoothly together. So that's just the validation that what we did in step 2 is actually worked properly. And then we monitor progress and adapt to changes and to stay on track. So those are the 6 steps. And like I said, this is my own explanation in simple words. There's no jargon here, I don't think. And I think this is a nice way to explain systems engineering to a senior leader. However, there's another slide which is more detailed, which I show here. And this is the system development lifecycle, which is a little messy. And maybe we don't want to show this to a leader, but it's up to you. Basically, there's 10 steps in the system development lifecycle. So you can see initiation, system concept development, planning, requirements analysis, design, development, integration and test, implementation, operations and maintenance, and disposition. And systems engineering is involved in all 10 steps. And so what I tried to do here was show where just those 6 things that I showed in the previous slide fit in to these 10 steps. So for initiation, number 1, understand the problem. For system concept development, number 2, explore all solutions. For planning, prepare for testing and support. For requirements analysis, manage and track requirements. For design, development, and integration and test, we want to ensure that all the parts fit together. So that's a big part of our job, is the systems aspect of it. So we want to ensure all the parts fit together as we design the system, as we develop the system, and when we integrate and test the system. And finally, there's monitor progress in the implementation, the operations and maintenance, and the disposition. So this is the way I tried to show how systems engineering fits into the system development lifecycle. So why systems engineering? Projects without systems engineering often fail because of missed requirements or late discoveries of requirements. Systems engineering ensures that the requirements are clear and we build the right system and build the system right. And systems engineering helps keep projects on track. It provides better control over costs, schedule, and quality. And without systems engineering, you might not know something is wrong until the project is over budget or delayed. Why systems engineering matters across industries: aerospace, defense, infrastructure, transportation, energy, healthcare can all benefit from systems engineering. And systems engineering is not just for engineers. It's also a manager's tool to keep any size project on track. So systems engineering is essential for complex, high-risk projects. And I have a reference here to a very good document, very good book that I actually gave a presentation on earlier. If you want to look back, it was called How Big Things Get Done. Okay, in summary, this is my last slide. Systems engineering makes business sense. So I want to convince the senior leader that it's a business, it's a good, smart investment. So systems engineering helps us to deliver projects on time and within budget. It ensures we get the system right the first time, avoiding missed requirements, integration problems, costly early mistakes, and delays caused by rework. So the bottom line is that investing in systems engineering protects against risks and boosts the bottom line. Okay, so those are my slides, and it's like I say, it's a short presentation, and I think it does get across the point that systems engineering is a smart investment. I guess, you know, it's up to you to determine whether you think I made the point or not. And you can give me your feedback today, right now, on it. And like I said, if you're interested in using any of these slides for your own purposes, feel free to contact me at ivan@policydynamics.ca, or hopefully I'll be posting this video on LinkedIn after I get the recording. Okay, so I'm open to questions and next steps if anyone wants to take the floor. And
Thank you, Ivan.
Ivan, you take control.
Okay, yeah, thank you. That very good. This recording will also be available on the INCOSE Canada chapter website. So you can find the recording there, and Ivan's contact information, etc., will be there. I noticed that John had put a comment in the chat, just some suggested additional steps of understand who the stakeholders are, and that's important. Identify your stakeholders. If you're doing a stakeholder requirements document, for example, identify who the stakeholders are, fully understand or elicit their needs. So those are the stakeholder requirements, and for that, you know, that could be through interviews, it could be through submission of needs directly from the stakeholders. Sometimes, you know, it's understanding their mission use case and maybe going on site and seeing, you know, what is it that they do and what do they need to do to achieve their intended goal. And thirdly, John said, understand the system environment and constraints. Of course, that's very important. And some non-functional requirements will most certainly come out of that.
That's great feedback. Thanks, John.
Yeah, that should say environment, not necessarily requirement. If you have to understand what the system environment is to make sure you can address all interfaces that need to be considered in the mission execution.
Absolutely, and the interfaces are so important, and failures most often occur at the interfaces, and that's why integration is so important, to prove out those interfaces. But we need to specify those interfaces really well, and that's where ICDs come in, etc. So I completely agree with you, John. Really good points. One thing I just wanted to mention too, to Ivan's slides, in the organization I'm in, prior to me joining, there was no formal systems engineering, but a lot of the system engineering tasks and activities were conducted by somebody, and usually different people. And so I did actually go through, and after reading Eric Honor's paper, which was referenced by Ivan, I did a search on hours that were expended on prior programs with whatever success they had, and found that we were spending about 4 to 6% on system engineering activities. And remember, at this point in time, not by a systems engineering group or system engineering role, but those were the activities. Since then, so several years later, fast forward, we now have a formal systems engineering group with processes, best practices. I've established a system engineering community of practice and tools. And so we're in far, far better shape than we were before. And now we are at about the 14, 15%, and with measurable success on our programs. So I personally vouch for that slide of yours, Ivan, and for the research and papers and presentations that that Eric Honor has provided in the past. But just thought I'd add that. So you may want to take a look at your own organizations. What are you doing? What are you investing in systems engineering? I guarantee it's worth it. Does anybody else have any comments or questions? There's nothing else in the chat. Oh, there is something.
There seems to be a lot in the chat, Ivan.
Ivan, shall we put these comments by the end of the AGM?
Yeah, we want to get into the AGM. So I'll take a look at the comments. I invite people to reach out to Ivan Taylor directly. Pending time, let's see how long it takes to get through the AGM. We may not have time to come back to this, in which case, please just talk to Ivan Taylor directly. But let's branch over to the